The objective of this project is to replace the pot with something better. In other words, one that works for the tone as well as for the volume. And I have disassembled, just taken one wire off this pot here, and I'll do a close-up shot of that. And I'm going to go ahead and I'm going to hook this up just like I hooked the replacement one. This is the original pot here, and I want to see if we get any of the startling jumps. Now, I suspect we will, because as I was adjusting the tone and as I adjust the volume, it crackles. It also gets loud all of a sudden. So for example, if we play an NPR and it'll be this, and all of a sudden it'll jump down and it'll go quick again. And that's the kind of thing that you would expect from a pot that isn't working correctly. So let's take a look and see if we get the same, or if we get a characteristic measurement in which it would confirm that the resistance is jumping and isn't linear as the replacement pot that I'm hoping to replace is. So we're going to go to 0.7, and I'm just slowly moving this knob here, as you can see, and it's reading, 150, 263, 200, and there we go, 381 ohm. And as you can see, this bar graph down here, it's showing you that the resistance is increasing. And there you go. And it right now it says 613.2 ohms. And then it's going to just jump into 0.7 kilo ohms. So the potentiometer is still going. This just ended up changing magnitude. And as you see, we can continue to increase the resistance. So right now we're at just about 1 kilo ohm, and I'm just trying to turn it as slowly as I can. And again, this bar graph on the bottom is very helpful so that I can see, whether I'm increasing or decreasing. If this bar graph went from here to here real quickly, I would know that maybe there's something wrong in this. So let me just continue to turn it here. So we got, let's see here, almost a 2.5 kilo ohm. There we go, perfect. .3 kilo ohm, 3.5 kilo ohm. Okay, so 4 kilo ohms, 4.6 kilo ohms, and there we go. So we got, approximately 4.7 kilo ohms with this, and as I was slowly turning it, I didn't receive any jumps. So I know, that the max that this resistance, that this pot has, is 4.6 kilo ohm, 4.67 kilo ohms, and that there isn't any large jumps in it, that the disc inside isn't damaged at all. Okay, so let's do this. Okay, I'm going to just slowly go again, crank it up, and you can, let's see here, if you notice, you see how the numbers are going up and down as I'm winding forward. That bar graph is really telling here. This is kind of the experience. Look at that, 58 ohm, 30, 128, 140, 6, 8. Those numbers right there are really telling. They're saying, hey, the pot isn't working correctly, there's something wrong with it. Right now it's saying 18.9 ohm. But look how much I've changed it. I've really gradually changed it, and you can see these numbers fly. So this really, leads to the expected values that you would expect, these random jumps that you would see when you have a bad pot. You can see how quickly it increases, and I'm trying to be as steady as I can here in the way that I'm turning it. And I did notice one thing is, if I move it really slowly, there are definitely issues in there where it'll start moving up and down very quickly. So yeah, it's difficult to tell at the higher. Maybe it's not as worn up there, but what we can tell is that, what we can say is that, look at, from the beginning as I'm turning this, look at the jump and look at that bar graph. You'd almost think it was a mic input. really going crazy all over the place. I've turned this about an eighth, maybe to a seventh, and it's really going up and down. So that's exactly what we would expect of a pot that isn't working correctly. Now the one thing that I should note is when I cranked it all the way up, I did notice that this is a little bit different in kilo ohms. This is 8.76 kilo ohms, and previously it was 6.87, something around that. And so we're going to get a different resistance. This means that this is for the tone. This means that if I end up replacing the pot, we're not going to get the same range, because the pot that I want to replace with goes to a maximum of 6.8 kilo ohms. Well, this one here goes to 8.75. So we're going to notice a difference, but I'm not going to be, probably too picky about that, because this is just a tone. So let's go ahead and replace it and see if that fixes the problem. Here's the old pot right here. I'm hoping you can get a pretty good picture of this. And if you can see that there's a switch here that when I turn, let me see if I can get that right side up there, that it clicks on and off, if you can see that. And that clicking on and off is basically when it clicks on, it allows the current to flow through, and then it flows through the volume portion of this pot. When it's off, no current is flowing and no power is being used. What I will do is I will measure how much current is being drawn out by this when this is off, and that'll let me know whether there's current going through here or not. So I just have it simply hooked up through that power button that we just talked about, that switch, and the other end of it is to the wire. Before I solder that on there, I want to confirm that it's not drawing any current. So right now I've got it hooked up, so I'm going to just hit my change of delta so that it's 0, and right now I've got it in just standard current here. I actually have this hooked up to amps, but there's no way that this is going to be drawing anywhere near 2 or 3 amps. So I'm going to go ahead and I'm going to switch this to milliamps here, so we can get maybe a bit more accurate reading there. So now we're at milliamp there, not amps. So let's go ahead and turn this on, and let's see if we can see that turning on, which we should. There we go, perfect. So now we're noticing that more amps flows through as we go ahead and turn it up. And of course, it's fluctuating milliamps depending on how much is being used.
The Association of American Railroads says more oil was moved by trains in 2012 than ever before. The main reason is
I'm going to change the pot, see if that's okay. This is the tone that I just replaced.
North Dakota and Alberta. There aren't enough pipelines in these places to handle all the new production, so drillers are turning to railroads. Generally, the safety record...
Okay, so here we are now. I went ahead and I got the potentiometers replaced for the tone, for the volume, and I went ahead, although I didn't show it in the video, and I replaced the LED. I say I replaced the LED, but I actually replaced the lamp. And it was a very ancient kind of these lamps here. You often find something very similar like this in a mag light. So I went ahead and I replaced this one, which was burnt out. And so let's take a test and let's see if we get the volume to smoothly ramp up, ramp down, same with the tone. Okay.
And privacy on the next Morning Edition from NPR News.
Join us for Morning Edition tomorrow from 5 until 9 here on Michigan Radio. In the weather forecast, showers and thunderstorms likely tonight. We'll have lows in the upper 60s. Tomorrow, partly sunny. It's going to be a hot day. We'll have highs around 90 degrees. Heat index values reaching into the
mid-90s tomorrow. That's the tone, and here's the volume.
There's a chance of afternoon rain and storms as well. For Wednesday, partly sunny with a chance of rain and storms, but it will be a bit cooler. We'll have highs in the mid to upper 80s. Michigan Radio is your NPR news station. It's 6:20.
Happy with that. And the last thing to test out here is the light. Now, there was only one lamp that they had in here that I replaced. It was located on this side here. There was not a lamp located over here, so the light distribution isn't going to be even. I'll go ahead and show you what it looks like now, but I'll go ahead and turn the lights off so you can see it. That's with it on right now. As I said, you can't see it, so let me go ahead and turn the lights off real quick. So there we go. So we've got a good light.